A true bosons usually it is indicating the iron bearing sulfide minerals, and definitely it is a give uh, economic economic possibility of iron deposit, and maybe it is present under the earth. And the size of bosons also important. Size, color, structure, texture, these must and should. It's these true bosons. It's having it's related to the limonite, and which bodies having some voids. It is a clues. It's a giving the clear clues for searching of a iron. And when you go into this is a false bosons. The false bosons contain transportation of a limonite, and it is found by the iron or a copper deposit. Iron of a sulfide derivation, sorry, derivation. If it is insoluble, the ferric state gets fixed as an indigenous limonite at the site former sulfide, and it is forming to the true bosons. The soluble ferrous state, which gets transported and precipitated as a transported limonite, and it is forming as a false boson. So that we can clearly say, based on above two statements, the true bosons which are having the voids and the structures of a limonite on their body, and it is forming as a iron or a copper. It is indicating as a iron or copper deposits. And when you come into this, is a false bosons which doesn't have any structures or voids on their body, and it is formed into the transportation. So that in a false bosons we need to get any mineralization zone. Yeah, limonite bosons, it's also useful as a guide. When you observe the outcrop, it is derived from the leaching of a semi-massive and massive sulfides, and which are have the contrast type, and it is related to a disaffinated porphyry type structure. And moreover, a great variety of limonite products, usually it is in evidence. A particular varieties such as a looking like as a cellular pseudomorphs, or which are developed on a large scale and generally stand out more conspicuously in to the unaided eye. The color of a limonite. The colors of a limonite, it's very important. Either it's having the limonite or in yellow or brown mushroom or in a red color also. And based on this one, Walker's type minerals also we can able to identify, that is a chalcopyrite, and a light brown and brownish. It is called as a sphalerite. Yellow and orange, maybe it is a borite, chalcopyrite. Maroon color, chalcocite, cobalt bornite. Dark brown to black color, it is indicating as a formation of a chalcocite pokers, and orange, it is related to the galena. And there are various colors which are indicating the formation of different types of minerals, and with using of limonite colors. And boxwork structure of limonite. During this oxidation, the grains of sulfide minerals, which are residual limonite remaining materials, and which are formed in a cavity, and it is showing as a honeycomb cellular patterns. So such type of the patterns are called boxwork, and persist in the limonite cap rock, which are formed in the original pattern. A coarse cellular These cold cellular type of structures we can able to identify in chalcopyrite sphalerite, fine cellular which is identified in bornite, chalcopyrite, sphalerite, and cellular again we can see into the sphalerite, columnar and botryoidal structure. We can see into the pyrite and pyramidal type and diamond mesh type. These structures we can identify in galena, molybdenite, honeycomb, and chromite. And some of the features, whites and leached outcrops. These structures also useful to identification of a mineral or which are useful as a guides to identification of a ore deposits. Such voids creates leaching and precedes minerals. Maybe it is a sulfide or non-sulfide derivations. And sometimes it's the abundance of voids of a sulfide derivation. It is indicating the abundance of the pre-existing sulfides. Oh, and again, if we go into this is the geological exploration for stage 2. And the stratigraphical, lithological, and structural guides we may study. Yes, definitely we can say in particularly if you can take a sedimentary bed, and the bed it's consisting of a stratigraphical sequence, the stratigraphical formations, and maybe if it has a host rock, maybe it is a host rock, and either maybe sometimes those sediment rocks also having the intrusion bodies due to the volcanic flow. And some the above mentioned principles all are applicable to searching of ore minerals. The same principles we can apply in a stratigraphic and in a lithological process. Okay, there are three types of geological exploration. One, it is a stratigraphical related. Second one, it is a lithological. And third one is the structural guides are important features when we are doing the geological exploration. How we can determine? Suppose if we can take the stratigraphic sequence of a sedimentary bed, it can be easily to determine either the formation it is related to the geological or not. And must and should these all we can correlated on a geological map, and we need to carry out the virtual actual field work where we are collecting the samples, and we can have a chance to predict and search for a mineral or ore deposits in the same area. And if you go into this one, and again, in deeper level studies, we have two types of a criteria. It is importance to us. One it is a syngenetic, and second one it is a epigenetic criteria. If you want, it is a syngenetic. Yeah, the syngenetic mineral deposits. A deposit it is a formed. A deposit it is a formed along the with enclosing rock, along the enclosing rock or any geological formations. That means if it is any geological formations already formed. So along the geological formations, either maybe it is the rock body or whatever it is there. Along with that one, again the mineralization deposit it will be formed. So that such type of formation it is called syngenetic formation. In exploration point of view, the syngenetic formations, it is less complicated. It has a less complicated, and it is compared to the epigenetic deposits. If the ore body it is integrated with a rock, and the rock itself also it is useful as a guide, and it's a giving the particular information within a limit. It is a giving the particular information of a rock, how it is the farming. In a structure, a contour map it's playing a very important role, and it's a very uh, convenient to depicting the shape of a ore body, how it is settled down on a position. In particularly in pegmatites, the metallic minerals are probably which are having the erotic in distribution. In many pegmatites, it consisting of a micaceous formations and adjoining the host rock of or adjoining its host rock through the graphic granite and the pegmatic feldspaths. It's related to central core or it's related to the core zone of a quartz material. And and the best example for this one, pegmatite of Nellore belt, Andhra Pradesh, and Godur. And if you go into the Tamil Nadu, which are available in the formation of a dikes. And coming to this is a epigenetic deposit. In a epigenetic deposit, the mineral deposit it is a formed subsequent to the enclosing of a rock. In a first case in syngenetic formation, it is forming along the geological formations. When you come into this here, the same mineral deposit, it is a form subsequent to the enclosing of a rock or a subsequent of a geological formation. This is a variation between the two. Yeah, if it is a replacement of ore bodies from a most sedimentary deposits, either maybe it is a syngenetic, but the entire area it is not favorable, or the entire area it is not formed as a stratum in the formation, or it is a replacement with a bed. Sometimes it is a controlled by the additional material. Like additional material means additional structural features like a fold access and all those things. The Indian examples, 5 Indian examples has given here. Typical sedimentary mineral deposits. It is occurred with the Precambrian rocks, which are located in South India. The mineralized deposits are limestones, and which are the formed or which are associated with the cement, flux, and chemical grade. And along with that one, the dolomites also we have seen, and it is a flux material. It is available as a refractory grade, and these limestones and dolomites occurring in Kadapa Basin and Karnool formations of Andhra Pradesh states. And particularly the main origins like dolomites of Vempelle stage, it is in settled down in lower Kadapa, and Narji limestones of a Jemmalamadugu stage, it is a Karnool system, and it is distributed in Karnool, Mahabunagar, Kadapa, and Guntur districts, and little amount of same areas we can able to identify in the Krishna district also. When you go into this Pakal system, where it is located in Khammam, in Telangana, the same limestones and dolomites of Bhima series we can identify in Rangareddy districts of Telangana, and less amount of same formations we have identified in Gulbarga, that is in Karnataka state. These are all which will become under the same category. Next one, it is a structural guides. In the structural guides, the pattern of principles, main it is a depend on the stress planes. And again, it is a uniform versus and non-uniform stresses. And it's related to the fractures, how they are getting the stress, and what are the causes, and what are the variations we can able to identify when the fracture patterns are forming. Stress. Normally if anybody, it is a having the elastic limit. If it is a limit, the limit if it is increased, if it is the force, if it is increased, maybe it is getting the cracks on their body. So that here the internal force, whatever it is there on this is the rock formations, it have a bit, it is a applicable within the elastic limit. The force it is called, the internal force it is called as a stress, and it can be resolved. It can be resolved and into the shearing and the normal components. Tends either to press to other sides, and it's plane together to pull them. And in a, if you can see into this normal component, the normal component it's pulled to apart from the original part, and then this part it is called as a tensile stress. Tensile stress. If it is a piece together, if it is a piece together, this component it is called, this component it is called compressive stress. Yeah, pattern of a principal stress and their planes. Every point in a stress body, it has four critical planes. Two are maximum shear, one of a maximum normal stress, and one of the minimum normal stress. But when it is, that means actually it has four planes in a stress body. Among these four, two, the main it is a maximum shear, and the remaining two, one it is a maximum normal stress, and another one it is a minimum normal stress. If the four planes, if it is intersects commonly, and it's a line and it's a angle at 45 degrees for each other. This is true, and it's regardless of this manner in which body it is loaded, whether it is acting as a by compression or internal force or a tension or a shearing couple or whatever it is. It is also regardless whether the body it is a homogeneous or heterogeneous, whatever may be. So that the stress is maybe sometimes it is a uniform or a non-uniform. Okay, based on this is a stress and the stress and the strain. The different mineralogical formations will be there. And next one, it is an echelon structure. The fractures which are arranged, it's very common factor in an echelon. Yeah, the best example for this one, the gold mineralization at a Kolar mine, and it's a source of excellent structural features, and it is a control besides stratigraphical formations, and the more it is localized along with the cyst belt in a zone of intense when it has a cross folding. The Kolar mine it is located in Karnataka. It is famous for gold mining. And next structure it is a sigmoid structure. It has a certain bean type of shape. So that conveniently the name it is called as a sigmoid curve. This is a reverse curve in which a line serves from its course of then the swings it back and again. It's resume to all the directions. It's parallel. It's a former course, but not in a line with the same. Such type of structurally commonly we can see in a pairs and forming as a cymoid loop. And again, the same structure we can able to see and we can suspect it in a vein type of structure. And next one, it is a horse tail structure. In a horse tail structure, it is also same, almost all the same properties like a sigmoid loop. It is forming as a horse tail structure, and again it has a group of or a series of branches. When it's a curve, it is forming from one side to another side in a vein. Such type of a zone, which are the plaques in very wide ore bodies, and these type of structures we can able to see in a beams and which are the formed uh, very numerously in a faults. And the attitude of veins during the fault. Some ore bodies it's related to directly to the faults in many cases, and the produce which are produced the fine grained gauge and the circulation of a ore solution, and it is prevented by the fault formations likely to be as a barren. Accordingly, faults a minor displacement it is occurred, and it's likely to develop very less gauge, and these are the best hosts to the ore formation, or these are the best hosts for the ore. So that these being type of faulting, it's also very important for the formation of a ore. And contacts. Contacts are very favorable places to formation of a ore deposits because of they have a very surface of weakness, so that these contacts which are giving the space in a rational proportions to formation of a veins, and these veins will be filled by the different mineralizations. And graph these the best example for this one, graphite deposits in Kavidigundla, Jiruguppa, Borugubanda, and other places within Konda lines of Eastern Ghats. And again, when you go into this is the east side of West Godavari, Khammam, and Vishakhapatnam. These type of deposits will get. And the folds. Sometimes these four bodies may we can found in parts of folds also, such as crests, anticlines, and troughs of synclines, and intervalling of limbs. And these parts which are favorable for deposition of a ore and depend on their local factors. And the best example for this one, predominance of an echelon pattern or an echelon structure. It is a favorable for the uh, colar and other gold deposits. And besides, also we can have a chance to get more copper deposits. And particularly come when you come into this is a gold mineralization, gold gold fields. It is associated with the cyst belt and which are having the cross folding. And one more example for this is one Gadaga district of a Gadaga gold belt in Dharwad district of Karnataka. It is localized and it has a dipping 50 degrees to 60 degrees. It's towards the western limb, and it's located the direction of north west and south southeast. The trending major cross folded. It has a syncline. It is marked by sub-parallel shear zones. So that here you can identify the one thing. You can understand the one thing. The folds are playing a very important role in the formation of the ore deposits. The best example for this one, it's already earlier mentioned the polar gold fields in Karnataka, and again Gadaga gold belt in Dharwad district of the same Karnataka. But it is showing the angle inclination between that is a that's maybe 50 degrees to 60 degrees, and again the west limb tends. West limb means the fold limb. It is a tends the direction. It is showing the northwest and south east trending major cross folded. We can identify in a syncline. The mineralization very rarely we can able to identify the copper quartz veins, quartz vein zones within a quartzite and adjacent areas of cyst along the shear zone. Where it is available means it is having the synclinal structure. The best example for this one, Agnikundala copper deposits, it is in Guntur district of Andhra Pradesh, and it's showing the excellent structural control features, and it has a intense of folding and drag folding. You go into this is geophysical methods. Yeah, in earlier we have studied some geological methods, and we didn't go detailedly in the geophysical methods. The geophysical methods also playing a very important role, also searching of hidden mineral deposits, hidden mineral deposits by the measurements of certain physical properties of Earth's surface. So that here there are, it is divided again into the 5 categories in a geophysical methods. What are they? The first one, it is a gravity. Second one, it is a magnetic. Third one, it is a electrical. Fourth one, it is a seismic. And finally, radioactive methods. These 5 methods are very important for searching of mineral deposits with using of physical properties in a Earth surface, which are useful to exploration and to locate the mineral deposits in a subsurface. Yeah, the first one we'll see the gravity methods. In a gravity methods, the gravity methods which are worked based on the local variation features, the directions and the intensity of a Earth gravitational field. Depend on this, the gravity methods will be used. And what's the main principle of this one? Yeah, this principle, it is involving to locate the where are the anomalies are presented based on the gravity, from one place to the another area in a searching. And again, uh, it's a having the gravitation, it's a having the plumb bomb method. Based on this is the plumb bomb method. It's moving very freely, and point it will point towards the center of the earth. If it is a heavy body, if it will be uh, nearby that one, and it will be moving or it will be move to that side. Because of the gravitational force, it will be working on the plumb bomb, so that it is showing the result. And the heavy mass body, the heavy uh, mass body, maybe it has a sulfide ores, iron ores, and chromatic deposits. All these type of deposits, or all these type of mineralogical deposits, we can able to identify based on their gravitational force with using of this the plumb bomb method. And next one, it is a magnetic method. Next one, it is a magnetic method. In a magnetic method, the structural features are the playing very important role to identification of a ore, and in particular magnetic methods we have been used to advantage of a tracing of a geological structures and geological contacts under the ground. And based on this one, we can able to identify the where the iron where the iron deposits were formed, where the iron deposits were formed, and where heaviest material was formed. There, this magnetic method will be applicable, and these are very useful to identification of different things. And again, where it was applied, it was applying in particularly where we can able to identify the uh, ore minerals other than iron oxides, or directly we can able to detectable, or sometimes we cannot able to detectable directly. And then this method at the time we cannot able to use, and where it is having the iron ore minerals like a magnetite, pyrrhotite, or a hematite, and there these type of methods it will be useful to us. And what are the rock formations? Yeah, what are the rock formations which are useful? These magnetite or magnetic methods which are useful in the formation of lavas, sedimentary rocks, and intrusive rocks, and frequently which are having the sufficient of trace contacts. And finally, it is a provide the structure. And next one, it is electrical method. The electrical methods, it's depend on their contrast of electrical properties between the ore body and the surrounding formation of rocks. If you are using to describe the structure, we can use the electrical properties between the different rock formations. And based on that rock formations, which are allow the electrical power through this is pores and which are having the mineral content, depend on that the fluctuation of power or electrical fluctuations. We'll take the measurements, and those rocks which are having the how much of the resistivity, based on that we can estimate, or we can come to the conclusion to which type of rock formation will be there in that one, and it's having the which type of ore deposits. And there are various techniques are there in this one, and some make use the conductivity and the self potential, while others make use inductive response properties of a rocks. When you go into this self potential method, the electricity or electrical energy, it will directly measured on a rock surface. In self potential method or ionization potential method, in these two, with the using of these two methods, we can able to identify the small pockets of sulfide deposits. If you go into this is a resistivity methods. In a resistivity method, particularly in a resistivity method, we can able to identify the metallic mineral deposits. Those, the current, how much it will be passing through this is a ore bodies. Based on that, we can estimate which type of a ore body it will be there in the formation. And the more the conductivity of most of the rocks, it's a much lower than the massive sulfide deposits. And here we can use different types of methods: resistivity, self potential, induced polarization, and downhole to the electrical methods. We can use the different methods in this section. And resistivity methods are measurements to find out the different resistivity of a rocks. Suppose in your resistivity methods, again it is having the two types of methods, or we are using the two types of instruments. One, it is a Schlumberger method, and second one, it is a Werner method. In a Schlumberger method, we have a electrical meter box, and it has a four rods. Those rods, one it is a P1, second one it is a P2, and these are having the, we are calling this is the potential rods also. These potential two rods, it's connecting with this is a box. This box, it's providing the electricity, and again two rods C1 C2 we are calling. These C1 C2 we can extend, or we can distribute on a surface. Then every 5 meters we'll disperse or we will extend the wire for every 5 meters, and then we can check the current. These current, it is indicating, or it is giving the information about the resistivity of a rocks. If the current suddenly, if it is increasing every 5 meters or 10 meters, then we can say there granitic rocks will be there. If it is decreasing after the 40 meters, then the current again, if it is decreasing, Just we can say yes, here some weathered part zone will be there. That means sediment or whatever will be there. In that one, again, we can see based on these rock properties or based on that mineralization properties, yes, these rocks are having the capability to absorb the more power or to transmit the more power through them. So this is a method. That means this is a resistivity method. It is indicating to study of a resistivity of rocks. And again, yeah, next one it is a seismic method. In a seismic method, that it is speaking about the capacity of rocks to transmit the earthquake waves. How much or what is the capacity it has, the waves, how much the intensity which are having, and how they are transporting to the one rock formation to the another rock formations. And so when they are passing through this one, it has a reflection and refractions. These based on these fluctuations, we can say the type of ore body. And some explosive also it's producing the artificial earthquakes. Yes, producing the artificial earthquakes. And the waves are measured by these very sensitive seismographs. Yeah, yes. There are two types of methods in this one. One, it is a reflection method, and second one, it is a reflection method. Based on this property, the rocks are having the which type of ore mineralization in that one, we can say very easily. And final method, it is a radioactive method. In this radioactive method, we can able to identify the ores of radioactive deposits like uranium, thorium, uranium and thorium. Yeah, in these methods, we'll have to use the uranium and radium, which are detecting their mineralization of radioactivity. Here, there are modern methods we're following. The first one, it is a Gregor-Muller method, and this device, it is a equipment. It is equipped with a meter, and it has a earphones also. And earphones meet it is a counting registers. Self-counting registers will be there, and if you bring into the field, just when we are walking into the fields with the holding of this one, automatically it will be reporting the radioactivity intensity reporting. It will be uh, recorded. And one more it is a portable gamma ray spectrometer. With using of this portable gamma ray spectrometer in the field, when we are walking on the field, and the physical observations also very need in this one. It has a gamma ray detector in this one. That means a gamma ray detector meter will be there inside of the box. And based on our physical observations like geological features, alteration zones, or of fractures and color variation in a rock formations. These based on these features, if you can put on a rock formation, it is absorbing the only gamma rays. Whatever gamma rays it is releasing to outside from the rock surface, and the same rays it is absorbing or it is detecting by this gamma ray spectrometer, and directly it is showing the results in a ppm level and percentage level. So this is advanced equipment. And one more thing, one more machine it was there, that is called as a scintillometer. scintillometer, and one more machine. It was a Syntrax. It is the Syntrax when we are holding in our hand and while we are walking on a field. If any radiometric zones or a radiometric waves or a gamma rays, it will be releasing to the surface. If it is releasing to the surface, it's absorbing by this the Syntrax. The Syntrax also it's having the internal parts of a gamma ray detector meters, and easily it is a detecting the gamma rays, and it is a giving the sound. It is giving the visual sound at outside. So that based on this sound, we can see the measurements on a scale or in a meter. Yes, the area it is having the radiation, or the area it's having the radioactive mineralization. So these are all the advanced equipments. These advanced equipments which are useful for particularly with identification of a radiometric identification of a radioactive mineralization zone in a radiometric surveys. And next one, it is a geochemical and geobotanical methods. In a geochemical and geobotanical methods, in the previous classes we have discussed about the geochemical and geobotanical methods. Again, we'll see the way detailedly. Yeah, what is the geochemical method? What is the use of a geochemical method in particularly to identification of ore deposits? In a geochemical method, first, what it is a geochemistry? The geochemistry means the study of elements and distribution of elements in a earth. It is called as a geochemistry. Based on this geochemistry, we have a chance to do the geochemical prospecting for different minerals and inclusion of any method for mineral exploration based on the systematic measurement. And again, we need to study the more chemical properties. Whatever naturally occurring materials will be available. These chemical properties measured in most common trace content, and again in group of elements also. In particularly, again, we go into this geobotanical surveys. In a geobotanical survey, it is involving a visual study of a nature and distribution of a vegetation parts and how it will be covered, and the plant's distribution. What are the indicator of plants and the presence of indicator plants, and some mutational or morphological changes in a species which are introduced by the mineralogical deposits or which are having the mineral enrichment. The indicated plants are the more useful to identification of mineral deposits, and it leads to the mineral exploration. The visual observation of the plants is also very important to identifying the mineral deposits. Visual observation means stem, plants, parts of like a stem, root, leaf, bark. These are all in a different color. When we are using these, it is useful as a guide so that it is known as a geobotanical prospecting. And again, when you go into this is a geochemical methods. In a geochemical method, the scale it's very important for an exploration point of view. The scales again it is depend on their surveys. The geochemical surveys are divided into the two parts. One it is a reconnaissance survey, and second one it is a detailed surveys. The reconnaissance survey. What is the purpose of this reconnaissance survey? In a reconnaissance survey, we have to cover the large area. It's a large scale of an area. Suppose if you are selected, 500 square kilometers of the area. But how to collect the samples in all aspects? You have to discern to be sampled in all areas, in all type of samples, like soil, vegetation. Vegetation means plants, sediment material, water, rock, and vapors also. We need to collect these all in a large scale or in your target area about in 500 and around 500 square kilometers. If you to do the with the choosing of a detailed survey, but it will take more time. But directly we cannot able to conduct the detailed surveys in that searching of minerals. So that we need to go to the reconnaissance survey. In a large areas, we'll collect the samples randomly and we'll to do the map in reconnaissance. To divide that area into the wherever our interest or our attention, we should focus on the areas, and we will eliminate the some barren areas. We'll collect the wherever our interest it is more. There we need to collect the sample. So that randomly we need to pick up the sample, or randomly we'll collect the sample in that area. So few samples we will be collecting. And these few samples are representative for remaining areas.
Here we are collecting the samples in selected areas, and it will be covering the total area, and it is a representative for a total area. Okay, now I'm stopping here. We'll discuss in the next class.